Howdy class. Today we're going to be finishing off chapter 4, and we'll also be talking about some more about these trigonometric equations. So we're going to start off with looking at cosine theta, and we're going to find that there is a lot more than just one solution like we've been talking about. Obviously, you know, cosine theta, that is the x coordinate on the unit circle. So if we draw the unit circle, so we have this unit circle right here. And I want us to note, you know, the only point where the x coordinate on the unit circle is 1, well, that's just right there, okay? So we can clearly see, when we set this up, that the only solution is 0, if we're restricted to one revolution, of course. And so, you know, this, you set this up, you take the inverse cosine of 1, and you can clearly see that, you know, in one revolution, it's only 0. However, if we do not have that restriction, we can see that this keeps going on. You know, it's also 2 pi, one full revolution. It's also 4 pi, and it keeps going on and on and on for any even number times pi. Now, right here, we're only including all the positive numbers, right? The counterclockwise revolutions, but there's also the revolutions in the other direction, right? Because we also want to include, you know, the negative 2 pi, negative 4 pi, and all those others. And so, one way to express this is just write it as 2n times pi, such that n is the element of all integers, right? And that little z means any integer. And that would be positive or negative. All right, so that would be our solution right there. Let's go ahead and throw some brackets around that so we know that we're talking about a set of numbers. And that's it. That's the solution for that one right there. So let's go ahead and take a look at the next example that we have here. And here we're going to go ahead and look at a new number, right? Again, cosine is the x values. And so now we're going to look at where we have square root of 3 over 2 is the x coordinate, right? And that'd be, you know, about right there. And note that that's not the only place where we have a positive x value of the square root of 3 over 2. We also have one straight down from that to right there. So we've got two different values here. Right? We've got one at pi over 6. And then there's another one here. Right, that would be pi over 6. Or you could call that 11 pi over 6, depending on which direction you're rotating. So when we set this up for theta, theta equals the inverse cosine of square root of 3 over 2. And so we've got, within one revolution, we have two answers. We have pi over 6, and we have 11 pi over 6. Now, between these two, I want us to note an important thing. We're not restricting our domain or range to just one revolution. We're going to keep going for all revolutions that are possible. So from pi over 6, we're also including everything that's an additional revolution, an additional 2 pi. So from 11 pi over 6, we also want to include, from pi over 6, we also want to include pi over 6 plus every revolution, 2 pi n. And then for 11 pi over 6, we want to do the same thing, 11 pi over 6 plus 2 pi n. And we can write this a little more succinctly like this. Pi over 6 plus 2 pi n, and then 11 pi over 6 plus 2 pi n. And of course you could combine this fraction and that number, but I think this is good enough for us right now, so we'll leave it like that. And of course n is any integer. Alright, so let's move on. Now we have tan theta equals 1. And so again, we are solving for theta. Now if you just plug the inverse tan of 1, you're going to get pi over 4, right? Because that references this point right here. And that is one correct solution. However, there are multiple correct solutions. In fact, there's an infinite number of ones. But even within one revolution, there is another solution, and that solution would be right here. And so we have pi over 4. And then we also have 5 pi over 4. So when we do the solution, again, we want to include all the solutions, so it's pi, not just pi over 4, represents that position, but pi over 4 plus any revolution, right? Plus 2 pi times any number n. So we would write this as the set of pi over 4 plus 2 pi times n, comma 5 pi over 4 plus 2 pi n. Now this does accurately describe all of the solutions. However, we can write this even more simply, because note that the difference between pi over 4 and 5 pi over 4, the amount that you have to rotate, is actually simply pi, right? In either direction, negative pi or positive pi, you're going to be able to transfer to either one. So we can write this even more simply as pi over 4 plus n times pi, where n is again any integer. So basically pi over 4 plus half of a revolution, any number of half revolutions, right? Half a revolution to get to 5 pi over 4, another half revolution to get back to the first quadrant position. And so this is a perfectly acceptable answer right here. And again, this would be such that n is any integer. All right, so now we have the sine theta 0.25. This is not one of our reference angles that we typically have, so we want to think about this in a little more abstract way. First, let's go ahead and get that circle back up. And we're going to be finding the y coordinate of 0.25. So that's going to be exactly 1/4 up our distance, right? Because you go all the way up to the 1 position right here. This value is 1, but halfway, that's 0.5, and half of that, we're at 0.25. And so that is what we're looking for. And now we're looking for a positive 0.25, so that's going to be on either side of the y-axis, right? Either one of those angles is what we are looking for. So we're looking for that guy, and we're looking for that guy. And so the angles will be from here, and then again, the other angle will be to there. So when you plug in into your calculator, the inverse sine of 0.25, and some calculators, it'll look like this: a sine of 0.25. That stands for the arc sign. And these are all different ways of saying the exact same thing. But when you plug that in, you're going to get the value. Your calculator will give you the value. 0.25 268 0 255 14 2079. Of course, you don't need that level of accuracy, but that if you get all the decimal places that your calculator can handle, or at least the my program on my computer can handle, that's as far as you will get. So this number right here, that's this angle right there. Note that it's also going to be this angle right here. And so to get this angle that we're looking for there, we're going to go a full pi, and we're going to subtract out that yellow. So to find that other angle, again, that's, pi minus this number. When you do that, you're going to end up with 2.8891. 23984 47714. Right, and then that will be for, those are the two values inside one revolution. Of course, we want to get them for each revolution. So the total answer, we're going to write it like this, and we're just going to truncate the decimal places so we're not writing a whole bunch. And so we're going to have 0.25268. Right, that's our first one, and we want it every full revolution, so plus 2 pi n. And then for the next one, we've got 2.8891. And again, plus 2 pi n. And that would be where n is all real numbers. And if you wanted to be, make sure you're including everything, you'd have an upside down A, which means for all n that belongs to the set of integers. I said real numbers earlier. I meant to say integers. I'm sorry. So that's what that means. All the integers, right? -3, -2, -1, 0, 1, 2, 3, so on and so forth. Okay, on to the next page. Kind of a big blank there, kind of threw me off, but here we are. We're here in 4.5, more trigonometric equations. We're going to build on what we just went over. Now we've got a slightly more interesting equation. We got cosine plus sine. But again, we're going to go ahead and take a look at the unit circle. We want to just kind of think about this, right? We're adding the x-coordinate and the y-coordinate on the unit circle. All right, so we want where whenever you add the x and y, you only get 1. This only happens at one spot on the unit circle, and that's right here. Because everywhere else, keep in mind, x squared plus y squared equals 1 to satisfy the Pythagorean identity. And the only time we get where just x and just y equal 1, well, that's going to be right here at this point here. And then again at this point up here. As a reminder, this is the point 1, 0, and this is the point 0, 1. Now, everywhere else, you gotta it has to be the x squared plus the y squared. And over here, the x value is negative, and over here, the y value is negative. So those two aren't going to work. Only the two that I have marked here and here. So we can go ahead and solve this as such. Theta equals 0 plus 2 pi n, and then it equals pi over 2 plus 2 pi n, which we can write more simply as 2 pi times n and pi over 2 plus 2 pi n. And again, this is for all values of n that are in the set of integers. Now this next one is going to be a little more tricky. We want to get everything in terms of either cosine or sine. So what we're going to do is we're going to take a look at cosine squared theta, and we're going to replace that cosine squared theta with 1 minus sine squared. So that we have this value right here. All right, now we're going to move everything to the left-hand side because we note that this does look like the quadratic equation. And so we're going to use the quadratic formula to solve it. So we have 2 minus 2 sine squared theta plus sine theta equals 1. All right, move the 1 over so that we have negative 2 sine squared theta plus sine theta plus 1 equals 0. So now we can see that all we have to do, we can use the quadratic formula and set it up like this. Sine theta equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Let me go ahead and color code that. Make sure that we're on the same page here. This is b and this is b. B is right there, the 1. And then we've got our a value here and here. And then we have our c value here. All right, now all we have to do is simplify this so that we have negative 1 plus or minus the square root of 9 over negative 4. Of course, the square root of 9 is 3. So this is negative 1 plus or minus 3 over negative 4, which gives us negative 4 divided by negative 4, which is positive 1, and 2 divided by negative 4, which is the same as negative 1/2. Okay, so those are our two values for the sine theta, right? That's not our answer yet, but that's an important step along the way because we got to take the inverse sine of both of those values. So we have our unit circle back here, and all the times that y is going to be either 1 which is going to be up there, or where it's going to be a negative 1/2, which will be either here or here. Right? Those are all of our potential values. Like so. So let's look at this first value. Right, theta equals pi over 2. And we want to include every revolution, so 2 pi n. And now we look at this next guy here, right? That is going to be 7 pi over 6. And then we include every revolution beyond that, so plus 2 pi n. And then we have our last value here, which is 11 pi over 6. And then again we add plus 2 pi n. Alright. And again, this is for all the n that belongs to the integers. So on to the next problem. Here looks like there was a little lift off the right hand side of the equation. It's supposed to equal 0. And so note that we have an opportunity to use the angle sum, right? We got cosine 3 theta times cosine theta, and then we have minus sine 3 theta times sine of theta. So all this becomes the cosine of 3 theta plus theta equals 0. So this becomes cosine of 4 times theta equals 0. So note what we're doing here is we are going to be taking the inverse cosine of 0 to find 4 theta. So the inverse cosine of 0, that is, where are all the x coordinates going to be 0? Well, it's going to be at the top and bottom of the unit circle. So at pi over 2, and then we want to include every revolution, and then again at the bottom, which is 3 pi over 2 plus 2 pi n. And note again that these are the difference between this angle and this angle, like inside of one revolution, of course, is simply going to be 1 pi. So we actually can write this a little more simply. 4 theta equals pi over 2 plus pi n, and that will cover everything both inside one revolution and every other revolution. Now we're not done, because we're looking for all the angles theta, not 4 theta. So what we're going to do is just divide both sides by 4, and we find that theta equals pi over 2 times 4, which is pi over 8, plus pi over n divided by 4. And let's just go ahead and combine those two fractions while we're at it. So we have pi over 8 plus 2 pi n over 8. And so we can write this as 1 plus 2n multiplied by pi, whole thing divided by 8. Alright, so either one of those, this one or this one, answer would work, but that is what we have. So have a good day, and email me if you have any questions over this assignment.